All right, so now that we've talked about LED volumes and Unreal Engine, I'm just going to take you through a practical walkthrough of the hardware side of what makes all of this work. So behind me, we have our actual wall, which we used for some of the core stuff. But if you can see, this thing's about 11 feet tall and probably about 30 feet long, I would say, with a curve. This is kind of like a L-shaped wall with a bit of a curve on it. Now, if there was more space in this stage, there would be more of a curve because you want to kind of create as much of a round shape as possible. The big volumes are at least 180. Some of them go 270, even 360 degrees if they have like fly down walls or things like that. But we'll come back to the wall in a second. So this is the computer room for this wall. Usually these are called brain bars. On a big volume, there would just be lines of desks with computer systems, because the bigger the wall, the more computer systems that it takes to run. So in this system, it's a 2-system wall. So we have one computer here, which is the main server. And then over here, we're just using this one today, but generally this is the render node is what it's called. And so you set up your environments and stuff on this, and then using in-display, these two computers are linked through the network, and you send it to here, and all this computer does is take that environment and send it to the wall. So this is the box with the 2 systems. Again, everything's networked together. With multiple systems on the wall, you have to use syncing software. These are running on Perforce. So basically, anytime you change something on this, it has to change it on this computer. Otherwise, you get problems. So it's constantly like saving and syncing the data between these two. Sometimes that can take a while, depending. And so over here on this system, we have the processor. This is the system that takes what's inside this computer and shoots it out and separates it. This is a Novastar system. So your main 2 processor companies are Novastar and Brompton. This is a Novastar processor. This you tell, so if you see here, this is Unreal Engine, which you've seen at this point, but basically this is our environment. So then using in-display, which is inside of Unreal Engine, and the processor, they communicate to figure out, okay, this image is going to be sent to the wall, and you send it in tiles, because while that's like a 4K wall, it's a series of 4K images, so it basically splits it up. Imagine that we had 4 monitors here, 1, 2, 3, 4, and just one image over all of them instead of 4 different ones. You could set up your desktop to say, okay, this is going to be the bottom left one, this will be the bottom right, et cetera, et cetera. So that's the same thing that's happening on the wall, except it's being done through this processor. So, there's a bunch of menu systems and stuff that you go through, and you set all of that up. When you send this over and in-display sends it out, it sends it through the processor, and then it runs through a bunch of different Ethernet ports that go up through there. The cables go up through the ceiling and then run all the way over to the wall. And before we go to the wall, I'll show you here. So this is essentially the back side of the wall. So a wall, regardless of how big it is made up of, these, what are those, like 1.5 foot? I don't know if they're 2 feet. Yeah, it's like 1.5 by 1.5 squares. So this is one LED panel. There's a ton of different makes and models of LED panels. They're constantly making them, making the pixels tighter together, the brightness, the resolution, all of that. And everybody's always racing to get like the next best thing. But basically it's just LEDs, and I'll take off. So each of these panels is comprised of 4 LED panels, right? And it's just a whole bunch of LED little lights. This is the back, these are the connectors, and they just pop in like so using magnets. And then you have your little, where is it at? The carabiner that just safety chains it, because sometimes these things can be very high up in the air, and even though they're plastic, you don't want them to fall on anybody. So that's that. Basically, the Ethernet cable runs in here, and this cable runs in here. So it daisy chains. So, if you can see here, this one connects into this one on both of these, and then that one connects into that. So the information is flowing across here, and then down, and then back across here, and then down, and then back across here. So that's what in-display and the processor is saying, is like, we're going to put image here, and then the next one here, and the next one there. And if that's wrong, then, it would be like those little slidey puzzle things that you used to play when you were a kid. It would look like that. The images would be all crazy and all over the place. So that's this. They basically snap together. Here's locks here. Locks, locks. So each of these lock together. Then on this side, these are, you can set the angles. So this here you have, 0 angle, which is just going to be straight across. You have +5, -5, +10, -10. Different LED panels have different angles built in, but basically that's how you create the angles. So you would look at your space, figure out what kind of design you want, figure out based on the angles, okay, we're doing a -5 degree angle every time, how much space you would need to complete your curves based on that. This is what's called a flyaway wall. So at this stage, we have our main wall and then a flyaway wall, which we also have hooked into the system. So lots of times we'll use this for lighting, right? Because the environment is a 3D environment. That means even though over here we're seeing, this station and stuff, there's stuff behind us. So whatever that is, we can project on this wall, put it here, so that if an actor's here, we're seeing that behind them, but then we're getting interactive lighting from the same environment from here. And lots of times that'll work good if, maybe you're driving a car and you have reflections, things like that. Anything that has reflections. If actor's wearing glasses, you might want a flyaway wall to, kick off that light, because this is stationary, but let's say this train was moving, coming in, maybe these lights were changing, different things, different elements that are creating dynamic lighting. A flyaway wall could come in handy. On a bigger wall, that's again why it's 360. They'll also have ceiling panels lots of times for that down reflection and top lighting. So that's that. This is trussing for that. There's all kinds of different ways that you can build a wall. These are just simple trusses that sit on the floor, get sandbagged down, and then you can stack them. There's locks up here, and you can stack higher and higher. Now, this wall, we'll walk over here. Let me go right over there so that we can see. So this is a custom build that they made. So they built all of this framing that goes down and shapes around, so it connects to the back of all of these panels to keep this whole thing from falling down. And each one's different. Again, the big massive volumes are giant trussing rigs like we saw over at the green screen stage. but huge, and scaffolding and connected to the grid up top and everything. And that's a lot of planning with different departments and stuff to figure out how much this thing is going to weigh with the size that you're building and what kind of support structures it has, what the ceiling can, handle. Like here, they had talked about putting a ceiling LED wall in, but the roof of the building is not coated to support that amount of weight. So they would have had to reinforce the roof if they wanted to put a LED ceiling in here. So they opted not to do it. Before they decided to move to Arizona, they were talking about putting in a DMX lighting grid, because DMX runs off those DMX cables and can communicate with the computer. So there's rigs where you can program all the lights in your Unreal environment to coordinate to lights on DMX routes. And then basically those lights turn on based on the environment that you load in. So that's another thing as well. And again, these panels, even though they're on, they can pop out. They turn off automatically because they're not connected. A good thing is, lots of times you'll have LEDs will go out, so you'll have basically dead pixels that you'll notice. You got to check the wall every now and then. Maybe something gets banged or, one just burns out. But the nice thing is you just have to replace that one little piece. And most of the time when you buy LED panels, they come with backup of the little panels. And then, we built a stage in Belfast, and the deal that we got with the LED manufacturer was they gave us a bunch to take with us, backup panels, but then anytime they would go bad, we could just send them back and the manufacturer would reimburse them. So that's a deal as well. That's mainly it. Again, if this wall wasn't here and this thing was twice the width, this would continue going around. You probably have, a wider curve. So the curve would maybe curve to here and then keep going around and duplicate on the other side. And you can have more of a 180 wrap with it. But that's essentially, all they are. They're just giant TVs basically. And, the real magic happens in Unreal Engine. And it's also a lot of where the problems happen, because virtual production is taking software that was built for video games and figuring it out how to make it work with, live event technology like LED walls, and then figure out how to make it communicate with cameras and tracking and somehow make it all work together. And every wall is different. Every computer system is different. Every camera is different. Every camera tracking system is different. And it's it's a constant, fixing problems, figuring out things. And, because Unreal is constantly updating, all the tech is constantly updating and evolving. Lots of times you can't just Google or YouTube and figure it out. It's you have to literally solve the problem. And so that's what keeps people pretty busy, and why there's always a lot of people involved in getting the wall to work right, from the environment creators to the brain bar operators to the virtual production supervisors and the on the ground people, just getting all of that to work. One other thing I want to touch on, this stage uses the MOSIS system. And basically, the MOSIS is a tracker that sits on top of your camera, and it has a 180 camera that's looking up. And if you look up on the ceiling, you see all these little white dots. These are reflective dots that the sensor sees, so it knows where it is at any time in this space. It's work to set up. Obviously, you got to put all those on. And then when you calibrate the system, you have to set a origin mark in the space and tell the sensor, okay, this is the origin mark. From here to the screen is X amount. from here to the same distance is this, and then the camera lives yay height, and you give it all those measurements, and then it knows, okay, here is the origin. This is the origin in space. Anytime I open up, this is where I am. And then it looks up, and so if it's here, it knows, okay, I'm this far away from the origin. And then it's constantly communicating with the computer to tell Unreal Engine, hey, this is where I am. So then Unreal Engine has the mirrored virtual camera inside the software that we looked at, and it adjusts that. And so it knows, okay, from this place, this is what we should be seeing and how far the depth of field should be based on the lens, because you also have to calibrate your lenses and let Unreal Engine know. So it's constantly mimicking what the real camera is seeing. And so in a perfect world, if it's all dialed in, what's being put up on the wall should resemble what the camera would see if it was literally in this subway underground station right now. So it's a lot of theory, and again, you saw a lot of it in inside of Unreal Engine, which makes it a little bit easier to understand. But I just wanted to kind of go through the main hardware pieces for this. You got your wall, which is made up of LED panels. You have your trussing structure. You have your camera tracking, and on the camera, you have your camera and your lenses, and then you have your processor inside there and your multi-node system based on how many nodes you have to run your wall. So that is a look at the hardware side of virtual production.